Hello and welcome to Algebra 2 tutorial. In this video we're going to take a look at the period and phase shift of sine and cosine functions. So we're doing more transformations. Last time we did the amplitude and the midline. Today we've got our last two, the period and the phase shift. So first let's just take a look at what this function will look like once we have all the transformations in it. So last time we learned that the a value and the c value change the amplitude and the midline respectively. So it doesn't matter if you're doing sine or cosine, they still have the a in front that's multiplying, and that's the amplitude, and they still have the c that's adding or subtracting in the back, which is our midline. So let's just double check to make sure we see what that looks like one more time. So here if I have a sine function that's graphed, if I change the a value, that is a vertical stretch, it changes the amplitude. If I change the c value, that moves the whole thing up and down. That is shifting this middle dashed line, which we call the midline. So that's what we've done so far. So now we're going to do the other two letters, the b and the h. So that is going to be the period and the midline. So first we're going to start off with the period. So first we got to make sure we know what the period is. So let's take a look at that. So I'm going back to my sine wave, and when I change the b value, take a look at what happens here. So one description of this would be a horizontal stretch or a shrink. All right, when we're talking about waves, we call that the period, and we assign a number to it. It is the distance it takes for one complete wave to occur. So here this is nice highlighted in red. You can see that that is one complete wave. Sine goes up, comes down, and back up. We call that one period. So we want to usually find that number. It will help us graph the function. So let's write some of that down here. So first, our period, let's write what it is. Period. This is the distance for one wave. How long does it take to do one complete wave? Another way of thinking about that is the horizontal stretch. Or I suppose you could look at it as the shrink as well, which would be the first thing we want to explore. With that horizontal stretch and shrink, what values for the b will give you a stretch and a shrink. So if I go back to our wave here, and I say take the b value, and I make the b value bigger and bigger and bigger, it shrinks it actually. And if you make the b value smaller, it stretches it out. So our b value's original value was 1. So I'll put it back onto 1. So if that's the original, anything bigger than 1 will shrink it. But then if I make it smaller than 1, it stretches it. So that's kind of interesting to see. But the main thing we want to look at is, if I know the b value, which in this case you can see is 0.6, what is the period? Now as you can see here, the period is definitely not 0.6. Even though my b value is 0.6, the period looks like 10.5 or so. So it's not a perfect match. There is a little bit of work that we have to do to find the period. So there is an equation that we have to have. This is an important one. So the period of a sine or cosine function will be 2 pi over the b value. Now the pi definitely means we're working in radians, so if we were doing degrees, 2 pi is just a full circle, so it would be 360 over b. But both of those using the b value will then give you the period. So let's try one. So when we have an equation, first thing we want to do is identify all of the characteristics. So the first thing I see here is the amplitude is 2. Next thing I see is the midline is y equals 4. So now the new part, the period. So using this 3, that is the b value. So that means my period is equal to 2 pi over 3. So when I draw this equation, I'm now ready to draw this whole thing. Oops, that was not straight. So I'll put my y-axis here. Now if I want to do a little quick estimation, where do I want to put my x-axis? So the middle is 4. We're going to go up 2 and down 2. So that means my highest number will be 6 and my lowest number will be 2. So I'm going to put my x-axis down here. So I'm going to be going up 1, 2, 3, 4, 5, 6. So at 4, I have my midline. And then at 2 is the lowest it will ever go, and at 6, that is the highest we will ever go. One complete period is 2 pi over 3. So I'll put the full period right here. That is 2 pi over 3. And then what we do is, because each wave has 4 parts, we're going to break up that full wave into 4 parts. So we're going to cut it in half, and then cut it in half again to give 4 parts. So when we cut 2 pi over 3, we cut that in half. Well, that is just 1 pi over 3. And then if we cut pi over 3 in half again, we get pi over 6. And so now technically we're counting, each line is counting by pi over 6's. So this is 1 pi over 6. This one is technically 2 pi over 6, but that reduced. And so this one will be 3 pi over 6. And yes, that does reduce, but I'm just going to call it 3 pi over 6. This one would be 4 pi over 6, and it reduces. So then if we kept going, 7 pi over 6, and then 8 pi over 6, because the wave does keep going forever. So now we're ready to graph this. It is cosine, so it starts at the top. So I'm going to come up here and put a dot there at the top. And then cosine goes from there. After 1/4 of the wave, we are in the middle, and then at the bottom, and then in the middle. And then here I have my red period marker, so that should be one wave. And yes, it does look like one wave, but it keeps going like this. So draw that wave. Just like that. So that is how we can determine and change the period. So there is one formula here that we do have to remember. All right, that's our first transformation. Now we're going to look at the phase shift. So first, what is the phase shift? So I want to show that to you graphically first, so you can see it. So we've moved our graph up and down, we've stretched it vertically, we've stretched it horizontally, so hopefully you can guess the last one that's left is if we take this graph and move it side to side. That is a horizontal translation, and so we also have a special name for it with sine and cosine functions, and we call it the phase shift. It slides the graph side to side. Let's first write that definition. So a phase shift is simply a horizontal translation. So it moves us side to side. There's no equation to memorize on this one. This number right here just tells you how far side to side you have to go. So we're going to graph this one by hand again to make sure we've got this. So again, I'm going to identify all the characteristics. So first, the amplitude is -2. My midline over here is y equals -3. I do still need to do my period. So here my b value is 1, so period is equal to 2 pi over b. So my period, if that 1 goes into b, is just 2 pi. Dividing by 1 doesn't change anything. But now I have a phase shift right here. So we'll call that just the phase, maybe, to abbreviate. We are going to go pi units. And if you remember transformations, a minus means we are moving to the right. So now we'll put all of those into a graph to see what this looks like. Let's see, to figure out where my x-axis goes, our middle is -3. We're going to go up 2 and down 2. So it looks like everything will be below the x-axis. So if our middle is -3, we're going to go up 2 to -1 and down 2 to -5. 1, 2, 3, 4, 5. So my midline is -3. So my amplitude will go up to -1 and down to -5. The period is 2 pi. So when I mark this on my graph, I need to make sure that I can show at least one period. So this will be 2 pi. And then we're going to cut that into 4 pieces. So 1, oh, you can't really see that, sorry. So 1, cut it in half, and then cut it in half again. So if we cut 2 pi in half, we get pi. If we cut that in half again, we get pi over 2, half of pi. So that's 1/2 of pi. This is technically 2/2 pi. This one will be 3/2 pi. So it's 3 over 2. This is 4 over 2 pi. Then 5 over 2, 6 over 2. And that keeps on going. That is really the hardest part there, is labeling your x-axis. You put your period down and then cut it into 4 pieces. All right, I think we're just about ready to graph this. Go back to red here. But now we have to do our phase shift. We've done all the old ones, now for the new ones. So this means my sine graph, which usually starts in the middle right here, is going to be moving pi units to the right. So now my graph starts right there. And so now I'm just going to use each of these tick marks to do each part of my wave. So sine starts in the middle. Because it's been reflected, it now goes down. So I'm going to go down to the bottom. Puts me right there. Go over one more chunk. I'm going to be back into the middle. Over one more chunk. Now I'm at the top. Over one more chunk, back down to the middle. And so now I've got my wave. But we should continue going backwards now as well. So if I go back one piece here, that puts me back at the top. If I'm going to go back one more, that puts me back at the middle. And so that is what this graph would look like. So this technically right here was the starting point. It had been moved to the right pi units. All right, that was nice and long. So we've now seen what the period does and what the phase shift does. Now that we kind of know what they do, we have to make sure that we can go from a graph to an equation, or backwards from an equation to a graph. So let's start with a graph to an equation. That's one that we haven't practiced much. So when we look at these graphs, we have to identify all the characteristics: amplitude, period, midline, And if there is a phase shift, we can decide to do that. And that's where we actually get some choice. Looking at this graph, I don't know whether this is sine or cosine or how far it's been pushed left or right. The wave eventually looks the same. So we're just going to choose one right now. Let's call this down here our starting point. So as soon as I choose that, I see my phase shift. This has been moved to the right pi over 4 units. We're starting at the bottom, so I know it will be a negative cosine. And then I need to find my amplitude, period, and all that good stuff. So let's first start filling this out. I know this equation is y equals negative, because we're starting at the bottom, cosine, again because we're starting at the bottom. I don't know the amplitude, so I left some space there. I don't know the b value or the period, so I left some space there. But I am seeing here that this was moved pi over 4 units to the right. So that will be x minus pi over 4. And I don't know the midline yet, so I've left that blank. So let's do that. So I look at this graph. I find the middle looks to be about right here. I'm going to double check to make sure that works. If I count up, 1, 2, 3, 4. If I count down, 1, 2, 3, 4. So my midline is in fact positive 1. And that also got me the amplitude because it counted up 1, 2, 3, 4 or down 1, 2, 3, 4. So my amplitude is 4. So thankfully all of those are pretty easy except for the b value. That one takes a bit. So let's take a look at this wave. What is the period? So if I start here, when do I get to that same point again? Not until here. So how far is it from pi over 4 to 3 pi over 4? If that's not super obvious, I can go back up here to the top. I can also take a look at this point. How far is it from there to there? That is the same distance. That's a little bit easier for me to calculate. That is pi over 2. So from there to there is pi over 2. Now the temptation is to put that number here, but sadly you don't. That is the b value. And we need, that is the period, and we need the b value. So remember our equation is, I'll do it up here, period is equal to 2 pi over b. So we know my period. The period is pi over 2. And we need the b value. So really quick here, we can cross multiply. We have pi times b is equal to 4 pi. Divide by pi on both sides to get rid of it. And you're left with b equals 4. So there we have our b value. And we have completed our equation. All right, not too hard there, but there's lots of pieces, lots of things you have to remember. The big piece is the period and using the period to find the b value. All right, I'm going to leave this other one as an example for you if you want to pause the video and try that one out on your own. The answer will pop up here in just a few seconds. So here is one option for the answer to this sine wave. I chose sine. I chose this as my starting point, so it's a negative sign. The period should be the same, and the b value should be the same no matter what. Your h value can be different depending on how far side to side you wanted to go, and your c value should also be the same as mine no matter what. All right, one more thing to do here. We have to go from equation to graph. So let's try out one of those. Again, we'll probably only do one of these. I'm going to choose the one on the right. I think that one's a little bit harder. So first, I'm going to identify all the characteristics. My amplitude, in this case, is 30. My midline is y equals negative 20. My phase shift is right here, positive 4. And my b value is pi, so period again. This is the tricky one, is 2 pi over the b value, which is pi. So the pi's cancel out there quite nicely, so my period is only 2. It's going to be a little bit nice for us. So now I'm going to draw this graph. So here's my y-axis. Now I want to be a little bit careful here to make sure it fits. So I'm going to think about my amplitude and my midline here for a second. So if my middle is negative 20, I'm going to go up 30. That would put me at 10. I'm going to go down 30. That would put me at negative 50. So I'm going to make my x-axis a little bit higher than usual. Negative 20 is down here. I'm going to go up to 10, but down all the way to negative 50. So put my midline in there. A full period is 2. And so I'm going to cut that again into 4 pieces. So if I cut it in half, I'll be at 1. If I cut it in half again, I'll be at 0.5. And that means this one right here will be 1.5. So it looks like we're counting by 0.5s. So this one will be 2.5, 3, etc., etc. And my phase shift, ooh, it looks like I have to keep going. I have to go all the way to 4. So let me extend my graph a little bit farther. So the next one would have been 3.5. And then this one would have been 4. So that is technically my starting point. It's been slid all the way to here. Alright, so now I'm ready to draw this graph. It is a sine graph. Sine starts on the midline. It's a positive sine graph, so that means it's going to be going this way up. And so at 4.5, it would have been at the top. And you can see I'm definitely running out of space going this direction. So instead of going to the right, I am now going to go to the left. So if I go backwards, at 3.5, I'm at the bottom. At 3, I'll be in the middle. At 2.5, I'll be at the top. 2, I'll be in the middle. Bottom, middle, top, middle. And so now I've got all the points for a full graph. Make it as curved as possible. And there you have it. So this one is very, very similar. Go ahead and try that one out. And then the answer will pop up here momentarily. If you want to pause it and try it out on your own, that'd be great. So you can see here the final graph. A few things to note. It was moved to the left pi units, so this is actually the starting point right here. It starts at the bottom because we have a negative cosine. The period is pi. I broke pi up into 4 pieces and put all that together, and you've got a sketch of your graph. All right, so that is the period and the phase shift together. Let me give you a few more to try out. See if you can, oops, let me get to it here. Oh, there it was. Try these 2 problems out. See if you can get those. One of them is going from a equation to a graph. The other one is going from a graph to equation. Good luck.